Alright, we're going to kick things off by taking a look at section 1.1 in our geometry. This first section right here deals with points, lines, and planes. And if you don't have your Cami set up, or um, you take your notes digitally, then that's perfectly fine. Just make sure you do have your notes taken on a separate sheet of paper, and you should be good to go. All right, so we'll start off with a few definitions always in the beginning. Right here, the first term that we have are what we call undefined terms. An undefined term is a point, line, plane. Those are undefined terms. They're only defined when we actually start labeling them. So as is, they are pretty much, they don't really have much meaning. So as we go through things, you'll notice some parts of our vocabulary will be blank, and then that's part of it's because we'll fill it in, or in the student journal, you'll notice that there are um, some diagrams and definitions that are actually already there. So we'll come back to point, line, and plane. Next up, we have collinear points, and these points right here are points that are on the same line. Okay, so points that are collinear are points on the same line. They could be 2 points, 3 points, but they are all on the same line. For our next term right here, we have coplanar points, and these are points that are on the same plane. Okay, so if you think about a plane would be a piece of paper, okay, or think of a wall, whether it's your ceiling, the walls to the left or to the right of you. That would be considered a plane. And then if there are points on it, let's say if you're to put like tacks, then those would be points on the plane. We'll come back to defined terms and some of these next ones right here. Now, intersection. This right here is a very big piece to our section. You'll see some of these questions, and they'll ask um, two lines. They intersect at a point. Is that true or false? Okay, and that right there is a true statement. And the next one right here is to remember that two lines intersect at a line. Okay, so two lines intersect at one point. So if you were to think of, let's say we have these two pens, and if I cross them together, they actually intersect at a point. When it comes to two planes, we have plane one right here. We'll call this a second plane. If I were to intersect them, hopefully like right here, if this was intersecting each other, you would see that there is a line, and that line happens to be this horizontal one where that notepad is, or that second plane. Okay, so that's therefore there are two planes intersect at a line. And this right here, you're not really going to find straight up in your book, but it's something that you should be able to understand as you actually go through the lesson. So let's go ahead and take a look at some other terms right here. The first one right here is that of a point. And I can go ahead right here. We have ourselves our markup, which happens to be like a highlighter. And we need to remember that a point has no dimension. Okay? And a dot represents a point. So that right there, making sure a point is pretty much a dot, and it could be anywhere. It could be in space. It could be on a wall or on a plane. It could be on a line. So it represents a point. And there's two ways for us to label them. If it's actually on a point, we typically write a letter to represent that point, or with the dot right here, or we could also say point A. Next up, a line. A line has one dimension. It is represented by two arrowheads. So if you look right here, you'll see that there's an arrowhead where the mouse cursor is, and there's another arrowhead right there. So those are the arrowheads, and that tells me that this line goes on forever. It does not stop. It keeps on extending. Physically, on a piece of paper, we're not able to show that it keeps going, or else we would run out of space, right? But the arrowheads tell us that they do keep going. Now, so we said that it extends without end. Okay, that right there is big. But one of the main definitions in terms for what makes up a line is that 2 points make up one line. And so, right here, through any 2 points, there is exactly one line. This statement is the one that you need to know about lines. All right, it is absolutely important, and make sure you memorize it. And we could actually flip the statement and say that in one line, there is exactly is made up of 2 points. All right. It says you can use any 2 points on the line, and if you take a look at it, we have 2 points A and B. When I label or name this line right here, we're going to name it line AB, or we could call it line BA. Both of those are actually correct. And if you look right here on this diagram, there's actually this lowercase l in cursive, and that lowercase l is actually telling us that this is also called line L. So if there's one letter and it's in cursive, lowercase, then that will also be the name of a line. And typically it's right above it or right below the line. We could also name it by using an arrowhead. So I used the 2 points A and B right here, and you can see that there is an arrowhead above it. And so that represents line AB or line BA. All right, so those are three different ways for us to actually name a line. Next up, we take a look at a plane. And this is not yourself an airplane. All right, this is a plane, and we say that it has 2 dimensions. It is represented by a shape that looks like a floor or wall, but it extends without end. And so I told you guys just not too long ago, hey, think of like your wall, think of your floor, your ceiling, all of those right there are your planes. Okay. Now, 2 points make up a line. You need exactly 3 points to make up a plane. Okay, or through any 3 points, not on a line. Okay, so 3 points that what we say are not collinear are make up a plane. So through any 3 points not on the same line, there is exactly one plane. You can use 3 points that are not on the same line to name a plane. If there's 3 points and you can draw a line that goes through them, then we do not have a plane, or you do not use those 3 points to label and name the plane. If you take a look right here below, I can call this plane ABC. I could call it plane BCA. I could call it plane CAB. All of those are correct names of planes. Now, up on the top right here, there is this uppercase M. And so with that uppercase M, that right there is also, and there's no dot next to it, so that tells me that is the name of this plane. And so it could also be called plane M. All right. So once again, we could call this plane BAC, plane C, say BAC, and we could also call it plane CAB. Make sure any combination of those three letters work. Okay. Moving along. So they talk about right here a few other nuances when it comes to the different segments or different parts of a line. Now, right here, once again, we said 2 points make up a line, so we have 2 points and we have arrowheads, and I know that this is line AB or line BA. If I take a look at this next word, segment, a segment is actually, you could have a line, but within that line or those 2 points, we could say that it stops. And if it stops, we'll go ahead and call that a segment. So it has 2 endpoints. That's the difference between a line and a ray, or a line and a segment. So in the segment right here, with the 2 endpoints in our diagram, A and B, we can call this segment AB. When I label this or name it, I can either say segment AB, or I could take AB and then draw a line above it, but there's no arrowhead. And that's how I know that this is actually a segment and not a line. Or I could call this segment BA. All right, so segments actually stop. We could technically say in this line we have a segment, and that segment is A to B. And when I say segment AB, what I actually mean is, and I'll go ahead and highlight it just for this instance, it's that length right there that I have highlighted in blue. And that would be considered your segment. Next up, we talk about array. Array has one endpoint, that's the starting point, and then it goes through another point and it keeps going without end. Okay, so array has one endpoint, and then it goes through another point and it continues without end. Now, when we label or describe array, we always start with the endpoint. Okay, so if I take a look at this first one right here, I will call this ray AB. I start with the endpoint, which just happens to be point A, and then it goes to point B. And what happens right here is that above it, I have one arrowhead. The arrowhead is above the point that the line or that ray is going towards. So with the one right below it, you cannot call this ray AB. If you do, that's incorrect. This one right here is going to be called ray BA. And there you go. Ray BA. B is the endpoint, so that's the first letter that is marked, written down, and then it goes towards point A. Opposite rays, rays that go in either direction. Opposite. So we have 3 points here. We can say that these 3 points are collinear because they are on the same line. And for opposite rays, typically we'll start with like the ray that, or a point that's in between 2 other points. And I can go ahead, if I go from C to B, then we can say that ray CB and ray CA right here, those are opposite rays. Okay, these two are opposite. They share a common endpoint. It's both going to have C, and then we write which point or which direction those points go towards. Those are your opposite rays. You'll notice that there are a lot of vocabulary terms, okay, when it comes to everything that we're working on. And so it might be helpful if you actually make flashcards. I guarantee you it'll be helpful. You may want to go on Quizlet, make your own Quizlet flashcards, and then to make sure that you guys go through that, okay, to help you memorize things. All right, let's go through our exercises. Okay, it says give 2 other names for line CD. Okay, and remember, I know that this is line CD because up above CD there are the arrowheads. So we have CD. I'll take a look at that right here and give 2 other names for it. And I'll give you a few moments to figure out what those would be. One of them is line DC. The other one right here, we could also say is line M. And that's based on because of this lowercase m that happens to be adjacent to the line itself. Okay, so those are two different ways for us to name line CD. Another name for plane M. In plane M right here. Remember, plane M is based off of this letter that happens to be on the bottom right. You'll notice that once again, when planes are named, you'll see a lowercase letter, an uppercase letter, usually on some corner of the plane. That tells you what the label is. Don't forget, 3 points make up a plane, 3 non-collinear points. So what you cannot say right here is line ABC or call this plane ACB. That you cannot do. What we can say right here is that we have plane. And I can say we have ACE. Okay, that's one. We could say BE. I could go EBC. Okay, so these are 3 different names that we could have to name plane M. There are a few others. It's just a mixing and combination, mixture of writing the letters in a different order. All right, so that takes us to number 3. Name 3 points that are collinear. Remember, if they are collinear, they are on the same line. So I can look right here. I see 3 points that are on the same line, and those 3 points would be A, C, and B. Name a 4th point that is not collinear with these 3 points, and that right there for part 2 would be point E. All right, and that would be the 4th point that is not collinear. And you can see that that one is a loner. It's off to the side. Next up, number 4. Name a point that is not coplanar with points A, C, and E. Okay, not coplanar with those points. Remember, if it's coplanar, these are points that are on the actual plane itself. If you notice up right here, this point D is actually not on the plane. It's on a line. And the way to think about it is what's happening here is we have our plane and we actually have a line that's going through the plane. Therefore, any point that's on this line is not going to be coplanar. So our answer for this right here would end up being point D. All right, moving along. For our next part, we're going to use the diagram to name some other things right here. What is another name for line PQ? I look at PQ in our diagram, and another name for it, we could call this line QP. We could also call this line J. Okay, that would be another. Next up for number 6, what's another name for line RS? And I'm looking at these points right here, and there are actually quite a few. We have ourselves, we could say RT is one of them. Line RT, because remember, T actually happens to be a point. I told you earlier, make sure you remember that 2 lines intersect at a point, and that right here happens to be at point T. So we have RT, we have ST is another. I could also take RS and flip the letters and say SR, line SR, And then finally, there's one last one. And hopefully you don't forget, we got this lowercase right there. And this is going to be at line K. Number 7, name all arrays with endpoint T. All right, remember, the endpoint happens to be the letter T itself, and then it's going outwards. Right, so this is T, and I look, there's 4 other points. Those ones can all go be named as rays. So I can start off right here, ray TR. I've got ray TS, and these two right here would be the opposite rays. Okay, so that would be one pair of opposite rays. I have next up TP and ray TQ as another. And these two are also opposite rays as well. Number 8, you're going to have to try to get creative, get used to drawing things and imagining things in 3 dimensions. Okay, that's something that you are going to have to get better at. And let's take a look. They say let's draw planes M and N that intersect at line K. You may not be great at drawing 3-dimensionally, but we'll get better at that as time goes on. So let's say right here, I've got my first plane, my vertical plane. Okay, so I'll go ahead and draw that out. What I'm going to go ahead and do is draw another plane that goes through it. And so I'll do that one right here in red. And it is going to go through. And right here, I'm going to go ahead and draw dotted lines. And those dotted lines represent what we call a hidden line. Okay? Hidden lines are lines that you know exist, but you just can't see it from behind. Because let's say it's getting blocked off. Like you should know that, let's say, what could we have here? We have ourselves this rectangular object. And you know that right here in the back, you can see the front, but you can't see the back. So if you were to draw this 3-dimensionally, you would put dotted lines to represent that. The last thing that I am missing right here is, remember, 2 planes intersect at a line. And let me go ahead and draw a line right there. Not the best line, doesn't go through it correctly. I can go ahead and do that again, but hopefully you get the picture. It should actually, let me redraw this out. And the line would do something like that. And we can go ahead, lastly, we'll label this, and I'll put a lowercase k to represent our line. And right here, let's go ahead and draw that out. And there's our plane. All right. Sketch the figure described down below. We got for number 9. I can go through this real quick. You should try it on your own before you take a look at it. Maybe pause it for a brief moment. But we have AB as a segment. So I can go ahead right here. I've got segment AB. And this right here is ray BC. So I would use B as my endpoint and then go ahead and draw something up, something like this, and I'll go ahead and include point C. So here's a segment, no arrowheads, and then my ray right here for BC, you'll see an arrowhead going towards C. Lastly, we have a line and a plane. This line K is actually in plane M. So what I could do is go ahead and just draw a plane. We got ourselves M right here, and I can go ahead and draw a simple line. And I don't need to draw points because they said that we can just go ahead and label this K. As long as I put a little lowercase k down right there, then I have myself I know that that is a line. All right, so here, that right there is 1.1 in a nutshell. Try your best. Make sure do your stuff. Work on big ideas. Make sure that you also um, show your work on a separate sheet of paper. There might not be too much work to be shown here, but and so you're mostly probably going to put answers down. However, if there was work, you would make sure you write down the problem. But for this one, if there's sketches to be drawn, make sure you sketch them out. Okay, don't just assume that, hey, big ideas is okay. You should actually try to work on the problems first before you take a look at big ideas. That would be the best and most effective way for you guys to do your homework. All right, so I would recommend that you look at the book, take a look at the section. I have all the problems listed on Google Classroom. There's an image there that shows you the different numbers that you're supposed to work on, and it's the numbers that are shaded in black. Those are the problem numbers that you are to work on that correspond with the book. All right. If you have any questions, make sure you feel free to ask me in class. And here is 1.1.